Notes, it should take about 15 minutes, actually about 10 minutes, and then we'll go over the ones that we couldn't do on the homework, and you should be good. Ouch. You lost your notes?
No, it's okay.
2 days ago, you left it.
I am.
All right. So, if you recall, we're estimating area under a curve, and we're using trapezoids to do so, right? Now, anytime you use an estimation method, it usually follows then you want to know how good is my estimate, how much error, how much is it off. So when possible, you would like to know or have a feel for how close you are. Now, today's then second part is about how close are you, how much error might I have. If you look at this picture here, say you had a picture like this, and you were using trapezoids to estimate the area under that curve. What might contribute to how much error you get when you use trapezoids? I'm looking for some variables that contribute to how much error. The concavity, that's exactly right. If the curve looks like this, then there wouldn't be much error. But if it had extreme concavity, then there would be a lot of error. And so definitely concavity. How much concavity? Would that be a direct relation?
So we did this last time, but you put other stuff down.
There you go. Thank you. Concavity. Thank you. Okay? Now, would concavity be directly related to error or inversely related to error? By that I mean the more concavity, the more error, or the more concavity, the less error? Directly. The more concavity, the more error. You will see then that in terms of the error, it's directly related to the concavity. Now, M is going to represent a measure of concavity. We'll talk about that in a second. But this M in the error bound formula is a concavity measure, the greatest possible concavity over the interval, so we know our error is less than this. That'll be an error formula. What else would contribute to how much error in the estimate using trapezoids? How wide? Now, if this region went from 1 to 5, that would be a heck of a lot different error than if this went from 1 to 500. It wouldn't just by nature of the units, that error be totally different that way. And so it's also the region itself. Would that be directly related to error or inversely? The more area, the more error, or the more area, the less error? Directly. That's a direct relationship, so you can see then that that's in the numerator also. It's directly related to error. And then the last thing is, how many trapezoids? If I use one trapezoid, I get that much error. But if I take 2 trapezoids, less error. And if I took 4 trapezoids, given less error. And so there's also the idea of number of trapezoids. Is that directly related or inversely related? Inversely, the more trapezoids, the less error. And so because of that inverse relationship, you'll see that in the denominator. Now then, the obvious question that you might ask then, okay, so the error is less than, I see the B minus A is important, the N is important, the M, why the cube, why the 12, why the square? That takes substantially longer to prove why those are there. I'm talking a whole period. So having done that once, it just wasn't working. People did. By the time I was 20 minutes in, they said, you know what, I don't care. Let's just go. So I'm not going to prove why the formula works where it is, although I'm inclined to. We're just going to go with it. I want you to understand at the very least why the B minus A is there, why the N is there, why the concavity measure is there, and how they relate directly or inversely. You do not have to memorize this formula. I will always give it to you. I'm not big on memorizing formulas. You just need to know how to employ it. Are you with me? So the idea then is, it goes like this. Say I wanted to not only estimate, but then I also wanted to know how good is my estimate. And that's when I would use this error bound. The first part, it'll be a different view of what we did earlier. When I go to estimate this, let's assume we use an equal subdivision method. I would probably sketch this to begin with, not really caring about the picture being accurate, just enough to help me figure out what I'm doing. If I use 3 subdivisions, then where are my subdivision points at inside? 1 and 2, yeah? Now, technically, the first one is not even a trapezoid, it's more like a triangle, but that's okay. When they're equal subdivisions, I can usually factor out some things to the formulas. What can I factor out? The height, which actually runs horizontally, remember, and the 1/2. The height is 1. The half is part of the formula for trapezoids, so we're good there. When we use equal subdivisions, this first height, f at 0, only happens once because it's only part of one trapezoid, trapezoid 1. But when I go to f at 1, that base is base 2 to trapezoid 1 and base 1 to trapezoid 2. So it actually happens twice if I were to combine my terms. The same goes with f at 2. It happens twice. But f at 3 only happens a single time because it's on the far edge. Do you remember that part? Okay. In this case, you'd sometimes pick up your calculator, but because this is pretty clean, we'll just do it without a calculator. The function is x cubed. So what's f cubed? Or 0 cubed, rather. 0. And 1 cubed? 1. And 2 cubed? And 3 cubed. 47. Therefore, my estimate is something like 1/2 and the sum. 2 plus 16 plus 27. So 18 plus 27, I'm thinking 45. My estimate is 45 half. We? Okay. Now then, the new part to the day is the error bound. It says give an error bound for your estimate. Notice it doesn't say find the error in your estimate. Why is that not the question? If I can find the error in my estimate, then I would actually know the real value. Now, that, I know we actually could know the real value here. But usually, it's not the case that you know the real value. If you knew the real value, you wouldn't be using trapezoids to estimate at all. You'd just be using the real value, right? So please don't say the error is this. It's the error is less than this. I'm giving a bound for my error. I'm saying my error, I can be sure my error is less than this number. Now, the b minus a and the n, those I plug in first because they're just plugging and chugging. The m, I'm going to find that off to the side of it. So what's b minus a in this case? 3 minus 0. It represents the region in the integral. You can look at the limits of the integration to find those values. What about the n? 3. It represents the number of trapezoids. In this case, you were told to use 3 trapezoids, so that's why we're using 3 for n. M. I'll leave that. Now let's go out to the side. All right. Now m is a measure of concavity, but more specifically, it's actually, because I want an upper bound, it's the greatest possible concavity I can get on the interval. I know you guys we don't usually think of concavity in degrees. We just see if it's concave up or it's concave down. There's actually a number attached to concavity. How concave is it? How much are the slopes changing? That's actually a number. M is a logically chosen, I'll come back to that, but upper bound on the value of, there's an error here, would you say it's on the value of the absolute value of f double on a to b? So here we go. F is x cubed. F prime is 3x squared. F double is 6x. So m would represent the max of 6x, or absolute value of 6x, on the interval 0 to 3. The greatest possible concavity measure I could get on that interval. Well, what's the greatest 6x could be using x's from 0 to 3? 18. 18 is my m. Okay? So, with that, then, I say the error must be less than or equal to 3 cubed over 12 times 3 squared times 18. I could clean that up. and say error is something like less than or equal to 3 over 12 times 18, or 9 halves. The most that my estimate could be off by is 4.5. I know it can't be off by more than that. So if I were to put these two together, this doesn't actually get asked for in our textbook, but it does in many textbooks, in college textbooks. You might put those together and say, I know the true area, or the true integral value, is between 45 halves minus 9 halves. It could be up to 9 halves below my estimate, or 18, and 45 halves plus 9 halves, or what is that, 27. I know the true area has to be between 18 and 27. Now, if I used more trapezoids, maybe 20 trapezoids or something like that, what would happen to this error bound? If I used more trapezoids, where would that be affecting here? The denominator. And so what kind of number would I get? A smaller number or a bigger number? Smaller number. What would that do to my window then? Instead of subtracting 9 halves and adding 9 halves, I'm subtracting and adding a smaller number. My window gets smaller and I start to get a better and better picture of the truth. You with me? Now in this case I actually have the ability to find the true. The integral from 0 to 3 is 1/4 x to the 4th from 0 to 3. That's 81/4. The true area is 20 to the 4th, which obviously that is in. But again, if I wanted a better picture and I didn't have the ability to find the exact, then I could tighten that window by doing more. You with me? Yes?
Why can't you just go infinitely close together?
Take the limit. That's a good question. You could, and surely that would take the error bound to 0. The problem is then that you would have to then go and do that infinite number of rectangles. There's no formula per se for finding the number of trapezoids. So that would force you to then do f at 0 plus 2f at 0.001 plus 2f at 0.002. That would force us to use so many trapezoids that would be effective. Now that said, it is often the case, especially in science, that you know the precision you want to reach, and you're trying to figure that, okay, I need to get my measurement, my accuracy to within this measure. How many trapezoids will I need so I don't have to do too much? Do you agree you don't want to have to go and do 50 trapezoids to get the error less than 10 if 20 trapezoids would do, you know? So it's then sometimes the case that you want to know, all right, what's the minimum number of trapezoids I'll need to get error here? I think I didn't paste this here, what is it? So if the question would be number of trapezoids to get error less than 10 to the negative third, which is 1 over 1,000, then that goes to a little bit of solving the error bound. I know the starting point is you set the error bound less than or equal to 1,000. I can do that because I know that if my error is less than the error bound, and it's less than 1,000, then my error is less than 1,000, right? So if I set the error bound of 3 minus 0 cubed over 12n squared times 18 less than or equal to 1,000, I'm putting in all the stuff that's still there. The region hasn't changed. The max concavity measure hasn't changed. What has changed is how many trapezoids do I need? So n is going to be unknown here, and I need that error to be less than 1,000. You follow? If I solve this for n squared, how would you go about that algebraically? Probably multiply it over there and move the 1,000 over. So maybe 3 cubed times 18 times 1,000 in the numerator over the 12 that stayed there. Do you agree? Go ahead and pick up your calculator, please, and give me a decimal. Just one decimal will be sufficient because we're not going to use a decimal in a second. If you like, I can clean that up. 81, it's the square root of 81, square root of 40,500, whatever that is. Something, what is that, more than 100? More than 200. 200 something. 201.2. Now, the idea is, the question you're trying to answer is how many trapezoids do I need? Now, obviously, you would say, well, you need 201.2 trapezoids. You don't use 0.2 of a trapezoid. How many trapezoids do you need? 202. Doesn't this round to 201? But would that get error less than? So yeah, you need to actually round. No matter how much above it is, you need to round all the way up to the next number. And so you would need at least 202 trapezoids. 201 just wouldn't get it done. The error would be too much. Follow? Follow. All right, right on. So let's try the ones off the homework that you could not do or weren't sure about maybe. And I believe there were 6 C and D, and 12 was replaced, if I'm not mistaken. All right? So once you get that out, I'm going to put up some good stuff here, and we'll get rolling. 0 to 1 x squared x.
Yeah, I did.
0 to not 0 to 1, 1 to 4.
It's not crazy.
N equals 4 was used. So A was a trapezoid estimate. I think I taught that okay enough for you to do, although I'll be happy to go back and do that again if you want. The integral value. C was where the error bound.
12 was replaced.
Oh, sorry, this is 6. Sorry about that. 12 I'll come to in a second. I apologize. 6. So the question on C, after you did your trapezoid estimate, the exact, which you rarely actually do, you don't really have that, but they're just trying to give you some easy ones to work with to practice it. The max possible error to your trapezoid. So an error bound for part A. So, again, I don't require that you memorize this, but you definitely, I'm going to give you the formula and say, here it is. Please don't come up to me and say, what does M stand for? Because to me, that's part of what, that's on you. M you need to know. M is an upper bound, or it's a concavity measure, a max concavity measure. Okay. All right, so in this case, the error is less than or equal to b minus a cubed, which is 4 minus 1 cubed, over 12 times, what was n for the problem? 4 squared, that's this. Okay? The function is x squared. Now, if I want the max concavity measure, then I want the max possible value. I don't care if it's concave up or concave down. So you're really saying the max positive or negative second derivative value on the interval. I don't really care what the greatest concavity is everywhere. I just want to know in this region what the greatest concavity is. So if f is x squared, f prime is 2x, f double then is 2. That makes it easy to find the max value. It's constant, so the max value is just 2. We really can't do anything but 2. So at that point then, the error is less than or equal to whatever we get out of that. So 3 cubed over 12 times 4 squared times 2. So what do we get? Something like 27 over 96. Seems about right. Very cool. All right, then. Let's go to part D. I believe part D is how many trapezoids necessary question. So D is number of trapezoids, so error is less than something, 1,000. Okay? Well, I know my error bound is b minus a cubed over 12n squared m. If that's less than 1,000, then obviously my error itself will be less than 1,000. So if I just get the error bound less than 1,000, I'm good to go. So 3 cubed over 12. Now n, I do not know. M, the concavity has not changed, it's still 2. So I set up this inequality and solve for n how many trapezoids I need. N squared would be greater than or equal to, that makes sense, because I need a minimum number of trapezoids, I need n or more. 27 times 2 times 1,000, all over 12, square rooted then to get my answer. Square root of 4,500, so square root of, what do I get? Something like 67 or 40, no, 60 or 70, yeah? 60 something? 67 point, or was that rounded? Was it? 68. It was a 67 point something, so we need 68 trapezoids. Or more. If you're actually doing the trapezoids, you won't use more than you need to. It's more work. Okay, you follow? Okay, let's go to 12, which is slightly different because there's a bit of a gimmick in there I want you to see. That's why I replaced this problem. I wanted you to get a problem like this in there. You're estimating, if I remember, the area under sine from 0 to pi over 2. Okie dokie. Do you want to talk about the estimate too, or just the area bound? Okay, so if I'm using unequal trapezoids, it's because I want to do this without a calculator. And I want to then choose points that are known to me without a calculator. So what are some sine values that I could find between 0 and pi over 2 without a calculator? Pi over 6, pi over 4, pi over 3. 1 trapezoid, 2 trapezoids, 3 trapezoids, 4 trapezoids. Okay, we can estimate. So here we go. If they're unequal subdivisions, can I factor out a height and a half? No, I guess I could factor out the half. I just don't do that. So the first trapezoid. Let's start with the height. What's the height? What's the delta x there? Pi over 6. And the basis would be sine at 0 plus sine at pi over 6. Sweet. The next trapezoid. What's the base or the height now? How far is it from pi over 6 to pi over 4? I think common denominator. Pi over 12. It's pi over 12 wide. And that would be sine of pi over 6 plus sine of pi over 4. The next region, how far is it from pi over 4 to pi over 3? It's also pi over 12. I think you'll agree 3 pi over 12 to 4 pi over 12 is 1 pi over 12. Sine of pi over 4 plus sine of pi over 3 for the bases divided by 2. And the last subinterval, how far is it from pi over 3 to pi over 2? Pi over 6, and the bases are sine of pi over 3 plus sine of pi over 2. Now, just like on the AP test, I guess I want you to take at least one more step to simplify the trig. You may not leave trig expressions unsimplified on the AP test. So, let's just use our trig skills. What's sine of 0? 0, and sine of pi over 6? 1/2. So I'll say maybe pi over 12 if I put the fractions together times 0 plus 1/2. Pi over 24 times, what's sine of pi over 6 is still 1/2. What's sine of pi over 4? 2 over 2 plus pi over 24. What's sine of Pi over 4 is still root 2 over 2. What's sine of pi over 3? 3 over 2 plus pi over 12, root 3 over 2 plus sine of pi over 2, which is, I think that's it. You can do it. Okay, now let's talk how much error. It doesn't look by my picture there's a ton of error, but let's see. The error is less than or equal to b minus a cubed over 12n squared times m. Now m you're going to want to pay attention to, okay? Save you some time here. You know the other stuff is pretty clear. Pi over 2 minus 0 cubed over 12 times. We used 1, 2, 3, 4 trapezoids there, I believe. So m is going to be something like this. The function is sine. The derivative is cosine. The second derivative is negative sine. When you're dealing with sine or cosine, it's typical to just use an m of 1. You know always that sine or cosine are always less than 1. You don't need to get into, well, if the interval is a little less, it actually would be root 2. You don't do that. If you see sine or cosine, it's common to just say, all right, I know the max is going to be 1. So we'll use an m of 1. It might not be the tightest window around the true solution, but it's just common practice, and most often you don't actually have such nice numbers anyway. So pi over, 8 times 12 times 16, whatever that is, times 1. So there's an error. It looks pretty small, 27 over, what is that? Something like 1,000, so it's pretty small. All right. That's good. 16? Oh, was that when you were trying to read this? Yeah, that's a 16. Okay. Other questions then on the homework? Or you're going to ask about 1. 5, did somebody say? 5 and 1? 2 and 14?
Number 13.
13?
Yeah, 3/4.
Okay. 4?
No.
Oh, okay. Okay, here we go. 5. 5 is the velocity function given 8 pi cosine 4 pi t plus pi over 2. They didn't ask about this in the last class. I don't know why. It was pretty rough. Time when it's at rest. Wouldn't you agree that that means velocity is 0? Which would happen when 4 pi t plus pi over 2 equals, what kind of situations does cosine come out 0? At what angles is cosine 0? Pi over 2, 3 pi over 2, and so on. So I would list a few choices and go from there. That would mean 4 pi t would equal 0 or pi or 2 pi and so on, which would mean t is 0 or 1/4 or 1/2 or 3/4 or 4/4 or 1, etc. So that's actually coming to rest quite a few times in there. That's unfortunate. Maybe we can use some symmetry here. All right, so total distance. Did I say calculator, no calculator? Yeah. Well, should we go calculator then?
I didn't know calculator.
How'd that
It's a
go?
lot of work.
Was it?
Well, yeah.
I tell you what I would do, just in terms of, yeah. I would definitely use a GABA symmetry. You know that the period 2 pi divided by 4 pi. Man, maybe I wouldn't use a lot of symmetry. 0, 1/4, 1/2, 3/4, 1. What's the signs to this? At 1/8, for example, 4 pi over 8. I think he's talking like negative. Oh shoot, man, 0. So it's like this, isn't it? Boom, 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 boom. 2 pi divided by 4 pi. Yeah, period is 1/2. Goodness gracious. Okay. So I would use symmetry. I would just do 4 times the distance from.
You could just multiply by 2 for the 2 meters. I did 0 to 1/4.
0 to 1/4, multiplied by 2 or 4?
It's only
By
by
two.
the positive there.
Oh, positive, so 2, I see what you're saying, 2, then I get you. Did you go 0 to 1/4? I'm getting that it's negative in that region. Or-
Yeah, so I did negative.
So you did, okay. So the opposite of 2 times, all right, I'm with you. Somehow choose a region that's positive or negate the one that's negative to get distance, so I'm cool. 8 pi cosine of 4 pi t plus pi over 2. At the very least, let's talk about how we could maybe integrate this without, you could use of this for sure. I wouldn't. I would do this, negative 16 pi, 0 to 1/4. I would, I guess what I call mental use of this. What would your u be? 4 pi t plus pi over 2. What would du then be? 4 pi dt. Now, in order for this all to go well, if this was truly a really nice derivative, then I would love it if next to this there was actually an inside derivative of 4 pi dt. Are you with me? Now I could say I'm going to make that 4 pi dt. I can put that in there as long as I balance it with undoing of its sorts. I guess you could also say I could borrow it from this. I don't know if that makes sense to you too. That's another school of thought. But you can put in your du and balance with the undoing it, and that's acceptable. So this is something like, I don't know why it's negative. Why did I put a negative there? I don't know why I put that negative there. So this is negative 4 pi, and then the antiderivative of that would just be the antiderivative of cosine u. The antiderivative of cosine u is sine u or negative sine u?
Sine.
Just sine u. And then you would sub that typically. And that to me feels like it makes sense. Now you can just check your work with the derivative. But I think I'm good. Negative 4 pi. So sine of, let's see, pi plus pi over 2 minus sine of pi over 2, I get negative 4 pi times negative 1 minus 1, so negative 4 pi times negative 2, I get 8 pi for my total distance. That's a good one. Okay. That's right. Very good. That's kind of a, as you get harder and harder problems, you want to avoid, especially definite integrals, if you can avoid actually use subbing it, then that's how you might approach that. All right, number one's a humdinger. Are you ready? I'm the one that's going to be doing all the work, so I guess I should ask myself, am I ready? You bet. Here it goes. It's going to be ugly, and just get used to it. You just persevere. Be careful with your details, and you're all good. Okay, now let's start. Lateral surface area. Lateral surface area is just pi r L, where L is the slant height. Now they say in terms of r only. Now L is the square root of r squared plus h squared. Fortunately, that's still not in terms of r only. So then you use the volume. The volume is 100 over, or 100, and if that's 1/3 pi r squared h, then h is 300 over pi r squared. You follow? Write small, by the way, because this is going to take me a couple slides or maybe more. All right, so here we go. The lateral surface area is pi r times the square root of r squared plus 300 over pi r squared all squared. Okay. I don't want to do calculus on that in step B until it's as clean as I can make it. So here I go. I'm going to clean this up. Pi r. This is r squared plus 9 with 1, 2, 3, 4 zeros over pi squared r to the 4th. We getting a common denominator, that would be pi r, pi squared r to the 6th plus 90,000 all over pi squared r to the 4th. Now I can't square root the sum, but I can square root the denominator, so I'm going to square root the denominator. Pi squared r to the 6 plus 90,000. Then I would get pi r squared. And so the pi's go away, and one of the r's goes away. So I'm feeling like r to the negative first, pi squared r to the 6 plus 90,000. Is my lateral surface area formula as clean as I can make it. You with me? Okay, now we're starting. Here comes the hard part. I want to know the minimum surface area. So I don't want to know where L prime goes negative to positive. So I need to take the derivative on it. So L prime then, or dl dr, is, by product rule, first stays the same, and the derivative of that is 1 over 2 roots of that, pi squared r to the 6 plus 90,000, times the derivative of the inside, which is 6 pi squared r to the 5th. Okay? Plus, second stays the same, pi squared r to the 6 plus 90,000 times the derivative of r to the negative first. That's the derivative of r to the negative first. Negative 1 over r squared. So I'm going to call this negative over r squared. All right, I want to look for critical numbers to that, but I'm not ready yet. So, let's see, what's the best way to proceed here? The common denominator would be, I need a 2 and an r squared and a root of pi squared r to the 6 plus 90,000. This guy had the 2. It needed one more r, and it had the root. So I would have had to have multiplied this by r. 6 pi squared r to the 6th minus. This guy had the r squared, so I need to multiply it by 2 and the root. Well, the root times a similar root would be just the thing. Pi squared r to the 6 plus 90,000. A little bit more clear. When I distribute, I have 6 pi squared r to the 6 minus 2 pi squared r to the 6. That's 4 pi squared r to the 6 minus 90,000 over 2r squared, square root of pi squared r to the 6 plus 90,000. I need to know whether this is 0 or undefined by the critical number theorem. Now, undefined would imply the denominator is 0. The denominator, however, is directly tied to all this stuff, what that root looks like. And that would mean the lateral surface area is 0. Now that's silly. The lateral surface area can't be 0. So that, the denominator zeros are a non-issue. I'm going to focus on the numerator zeros, not equal to 0. So if I look at the numerator zeros for my critical numbers, and I get r is the 6th root of 90,000 over 4 pi squared. That's fine, I guess I'll leave it like that. I suppose 22,500 over pi squared, whatever. That's cool. That's r. In terms of what I'm looking at there, is that a minimum? Well, imagine if r was less than that. R would be small. If r was small, then this minus that would probably be a negative result. If r was big, then this would be bigger, so I'd get a positive result. So I feel like I'm getting a min surface area there. I think that is a minimum. And therefore I can finish the question. I know the radius here generates a min. The height that's attached to that would be 300 divided by pi and that thing squared. So those would be my components. That was a humdinger, huh? Okay, number 2. 2, is 2 still a question? All right, the variable force of that thing is applied to a moving object, work from 0 to 4. So did you set up the work integral properly, 0 to 4, 16 minus x squared, like that? Or is that the question? Dx is, so the idea, I guess the real idea at hand is you're moving it from x equals 0 to x equal 4, and I imagine mud puddle is how I think about this. The amount of work it would take to push this box to that spot, if this were on an even surface, like you probably did in last year's algebra-based physics, then it wouldn't require calculus because the amount of force applied at each here is always the same. So it's just a force applied over the total change in x. In a case like this, the force varies at the x, so you can think of it as maybe it needs more force to push it over here, and maybe a little less force to push it that same distance over here. So what they're saying is to talk about the total amount of work, you'd have to break it into tons of little calculations, like the force at this region times a little change, or how far you're going to change it and then make a totally different force at this time because the force has changed now, and then you'd have to add all that. Now that obviously is what the integral does. Now as far as the x, here it is. Yeah. It's tiny little changes. Now the other part of it was a calculus idea or a technique idea. That's hard to integrate. It requires a method called trig substitution, which you haven't learned yet. The expectation is that you do this geometrically. That matches the equation 6x squared plus y squared equals 16, which we know to be a circle. But because y is positive, it's only the top half. And because it's 0 to 4, it's only the right half. And so you're really supposed to do this as just, oh, it's 1/4 the area of the circle. Do it geometrically. Okay. 14. Question on 14. Is that a question on today's stuff?
Yeah.
Okay. 14. Golly, I have a technique I'm going to throw at you and see if you like it. If you don't like it, then I'll do it another way. Actually, never mind. Maybe I'll just do it the other way. I don't want to. Generally, students don't tend to buy into it. So, would you agree that x goes to infinity and sine of 1 over approaching infinity approaches sine of 0, which is 0. So this is an indeterminate form. Alrighty then. we try and make it a quotient to use L'Hopital, which means which one do I want to put in the denominator. It's really your call. Another one, it's never going to be pretty, so don't think, well, there's one great choice. It's not going to be a great choice. It's going to be ugly either way. So deal with it. Sine of 1 over x, and I'm just going to call this 1 over x. Now that also is indeterminate, but it's a L'Hopital case. It's 0 over 0. Sine goes to 0, 1 over x goes to 0, so 0 over 0. So by L'Hopital, this limit is equivalent to, now here's where we're careful with our derivatives. Derivative of that would be cosine of 1 over x, but times the derivative of the inside, which is negative 1 over x squared. Derivative of the bottom is also negative 1 over x squared, which is delightful because those divide away. That then approaches cosine of 0, which is that make sense? Okay. 13. Is 13 still a question? Yes, indeed. Okay. 2x over the limit as x goes to, is it negative 3? Negative 3. 2x over x squared plus 2x minus 3 minus 3 over x plus 3. I don't even know if I wasted my time looking at each individual. I just said, oh, forget it, I'm just going to put them together. How about we do that? So if I put these bad boys together, the first stays 2x, but the second, 3 would have to get multiplied by x minus 1. And let's say I'm looking at this the wrong way. So I get 2x minus 3x, which is negative x minus 1, minus 3. Plus 3 is what I need to say. Plus 3, right? Over x plus 3. That was maybe wishful thinking there, so I could cancel, but that's not happening. All right, so we cool on that, yeah? So this is a good review question. It helps me greatly to think visually. Wouldn't you agree that this is a rational function with an asymptote at negative 3? Not a whole? And in terms of what would behave, how it would behave at that vertical asymptote, I would fully expect there to be a sign change around that point because it's first degree. I would think it's going to be negative on one side and positive in the other, or vice versa. So I'm thinking this limit will not exist because of that one-sided limit difference. I guess to get the evidence in the record, I'm going to have to actually stink and figure it out, but whatever. So the limit as x goes to negative 3 from the left, and feeling infinity and negative infinity, which one? Well, say left would be less than negative 3, so maybe negative 3.1. Okay? So this would be positive. This would be a very small but negative number. Do you agree? So small. And negative 3.1 minus 1, that would be a negative number. So it feels to me like this would be positive infinity on this side. And if I looked at the other side, at the other side, this would still be positive, but this guy would be small positive numbers, negative, so this is negative infinity. And so I would conclude then the limit does not exist. The one-sided limits are not equal. You're welcome. That's a humdinger. Okay. Other questions? Yes? 3B? Okay. Yeah. Yeah, it's a bit of a mess. The hardest part for me was getting the equation. After that, the calculus was pretty okay.
Good morning, Delaware Jaguars. Please rise for the Pledge of Allegiance. Ready? Begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
All students, Boys Mentoring will be having a soccer tournament today. Please report to your room for attendance and snacks, and then meet outside ASAP. If you have a conflict, please explain to your mentee or mentor ahead of time. See you there.
Girls Mentoring is taking applications for group leader positions for the 2018-19 school year. Please join us for an interest meeting on Monday, March 12th, 37th hour at E100. Any questions, contact Ms. Harrington or Ms. Roberts.
I got started by saying, all right, I
There will
want
be
to talk about the distance between the two, so I use the distance formula from point to point.
Interactees, we need your help at the meeting today. Join us in the library and get your hours.
Senior high students. Jags, if you're at all interested in joining Dublin's nationally competitive cheerleading squad, please come and join us Thursday, March 16th.
I want to know how it's changing my
Informational
time,
meeting.
so I want to
Come by and
differentiate
learn
with
about the
respect
squad
to
and
time.
enjoy some snacks. Can't tell us you don't like Disney, go Jags.
Broadway Training Intensive in Denver is offering Hamilton Audition Workshop with
I
Dorothy
thought
Bloom
for
on
some
Saturday,
reason
March
I only went
17th.
to Y, but because I know both X, both Y, and the rates have changed for both.
Trinity University from San Antonio, Texas is hosting a Get to Know You session for
Um,
juniors and seniors
I think
on
it does
Sunday,
this, right? Just take
March
a visit with all
18th
three,
from 9 to
so
3 p.m. at Starbucks in Greenwood Village. Plus RSVP, see counseling if interested.
Junior high students, if you're interested in
And then the
being
derivative
part of
on
the
this with
Larry
respect to
Plays
time.
and February, there will be a brief informational meeting today from 2:30 to 3 in the auditorium. Whether you want to be on stage acting or behind the scenes on crew,
And then
join
I
us to receive a
had
list of
everything I needed. I knew
expectations
X,
and
Y,
applicants.
Gibson, CDY.
Senior hires who would like to help with the production should plan to be at the meeting on the list. Also, here's your sports for this weekend. Tonight, girls soccer, home versus Hatfield at MAC at 6. Then track and field tonight at Defco Stadium. Baseball tomorrow, Runyon Field against Pueblo County at 10 o'clock. And then boys swimming at Carmody Rec Center at 5 against Evergreen. That's all your announcements. Have a great weekend.
Oh, no, you need to put in stuff. I didn't remember what DXDT was. They gave it to you, but I didn't remember if it was 2/5 or 4/5. 4/5. So you should have everything you need to do it at the instant they ask you about. So you're home free from there. And I'm going by memory from my DYDT also. I thought it was it. You found it in part A. All right. Well, that's one more period down, closer to Friday afternoon. Oh, just that.